Alright guys, another video here on Absolute Extrema. This is something we really want to get good at in class on how to find the absolute max and min on an interval. And so the key thing here, I think, to note right now is that anytime you're doing a problem that involves absolute, you're finding the highest point and the lowest point on the interval. So the fact that there's an interval is really important. And the fact that it's the highest and the lowest is probably really important also. And whenever you're doing these problems, this is kind of the setup that you want to see. This table down below here is kind of a skeleton view of how you want to show your work. On an AP test, you want the AP graders to really understand your thought process. So everything's got to be pretty well organized. So we do this thing where we set up a table and we have the left endpoint, the right endpoint, and all the critical numbers kind of organized. And once you get the table set up, the way it works is the endpoints come from the interval. So if you're finding the max and the minimum value on an interval from A to B, where A and B are numbers, then x equals A is your left endpoint and x equals B is your right endpoint. And you go solve, you do all the math to find the critical numbers, and those could be, lots of different values. So I'm going to write x equals C is the critical numbers. And you take all those numbers and you plug them into the function. You figure out what is f of A, what is f of the critical numbers, what is f of B. And whatever one turns out to give you the biggest answer is your max, and whatever one turns out to be your smallest answer is your min. Kind of makes sense. So let's try a problem. We're going to do two examples for the video. And the first one is this. Find the absolute max and min for f of x equals x cubed minus 3x squared plus 1 on the interval -1/2 to 4. So first step one to this problem, is you want to look at it and say, I need critical numbers. Now, usually you're going to get this problem in a non-calculator section where you can't touch your calculator and you can't graph it. So keep that in mind. So we need to find critical numbers by hand. So we're going to use the derivative, and we're going to find f prime of x. And when we derive this thing, it's kind of a quick, easy power rule. X cubed becomes 3x squared, minus 3x squared becomes 6x, plus the derivative 1 is 0. Okay, so there's my derivative, 3x squared minus 6x. Now we're going to set the whole thing equal to 0, and say 3x squared minus 6x equals 0, and we'll solve for x. And I think to solve this, what I'm going to do is factor 3x out. If I divide 3x out, then I just get x minus 2. And if both these things equal 0, then either I have 3x equals 0, or I have x minus 2 equals 0. And so to solve for x, I'm going to divide by 3 on both sides, and get x equals 0 divided by 3 is 0. There's a critical number. And if I added 2 to both sides of this equation, I'd get x equals 2, and there is a critical number. And nicely enough, both of these numbers are on this interval from -1/2 to 4 on the graph. So that's a good thing too. Now, besides finding the critical numbers by setting it equal to 0, we also want to know, does the derivative ever not exist? Does f prime ever equal d and e? And in this case, because f prime of x is a polynomial, there's no fraction, so nothing's going to make this d and e. You can put any number in for x and you'd be fine. This is not going to be a scenario where d and e is going to matter. If it had been in a fraction, I would have been more concerned, but it's not. So let's set up our table. Let's practice organizing our work the way an AP grader would expect us to. So endpoints, let's do endpoints first. So the endpoint was x equals, we look back here, it was -1/2. So we're going to put x equals -1/2 as an endpoint. The right endpoint was x equals 4, so we're going to write x equals 4. And we got two critical numbers. We got x equals 0, and the other one we got was x equals 2 for our answers. And now what you're going to do is you're going to take all those critical numbers and you're going to plug them back into the original function. Now the common mistake here is most people go back and start plugging it into f prime, the power rule thing that we did, but you don't want to do that. You want to plug it back into this original f of x function. So I'm going to find f of -1/2 by plugging it into the original. I'm going to find f of 0, f of 2, and f of 4. And this part, for the AP graders, when they're looking at your work, you might show substituting the number in. But the math, I mean, a lot of it you can do in your head. You just want to be real careful to do it correctly. So we're going to have negative 1/2 cubed minus 3x squared. So minus 3 times negative 1/2 plus 1. And we'll do that math. And if you plug that in and you're kind of careful to do it, it should turn out to be 1/8. 1/8. So I'm going to go through and do that for all these. I'm going to do 0 cubed minus 3 times 0 plus 1. Well, that's going to equal 1. I'm going to do 2 cubed minus 3 times 2 plus 1. And on each of these, I think I'm forgetting to write the little squared symbol on the second piece here, squared. And that's going to clean up, and that's going to be negative 3. And I'm going to plug in 4 and do 4 cubed minus 3 times 4 squared plus 1. And that's going to be a bigger number. That would be 17. So I go through and I get all these answers. And once I kind of have those figured out, now I can identify which one of these is my lowest value and which one of these is my highest value. So the biggest number I see on here is 17. And that happens at x equals 4 here. So I'm going to write down here x equals 4 is a maximum value. And the smallest number I see is this negative 3 here, and that happens at x equals 2. So x equals 2 is a minimum value. And we have our answers. 4 and 2 are a min and a max. And sometimes I like to put that in a final column of my table over here. I kind of ran out of space, but I try and kind of throw that to the end of my table where the min and the max are. Now, most likely this would be in a non-calculator section, but this is just notes in a video, so you kind of have the luxury of getting on your calculator and making sure you're actually doing this correct. So what I would do after I do all this work, if I was doing a worksheet in class or at home, is I would graph it. I would graph this original function and see if my answer actually makes sense. So do that. Pause the video and graph it in your calculator and make sure your answer makes sense. Now you should be getting this because we got our values. We're going to plot some points. Now look at your table here. At x equals 0 at the critical number, we got 1 as an answer. So we got 0 and 1. So what I'm going to do is go over here and at 0, put a dot at where 1 would probably be. So there's a little dot there. We know that 2 was a minimum value. At 2 we got negative 3, so somewhere down here. So I'll make a little negative value at 2. And then we also know that if you look back at our table here, at 4 we got 17. That was our maximum value. So at 4 we're going to be up here at 17. So I'm going to go up to 17, which will be right around, we'll say right around here. And I'm going to connect this graph. Now if you're doing it on your calculator, you've already kind of seen what this graph looks like. It kind of goes up, back down. I think it crosses through 3, something like that. This is my graph of f of x. It's a little messy. And sure enough, if we're studying the interval from negative 1/2, that'd be over here, to 4, that'd be over here, then we can tell that the absolute minimum spot is at x equals 2. Here's your min. And the absolute maximum spot was supposed to be up here at 17. At 4, 17. That is our maximum spot. So now this is really, really messy, but you kind of get the idea. You can look on a calculator and see if your table says that x equals 4 is a max and x equals 2 is a min, then on your graph it should be a min at 2 and a max up here at 4. If it doesn't look like that, then something's wrong. Now that's kind of when you have the luxury of your calculator to do that. So here's one. You might pause the video and see if you can do this. Find the absolute extrema for f of x equals 2x minus 3x to the 2/3 power on an interval from negative 1 to 3. Okay, so remember your steps. Step 1, let's just start by getting our critical numbers. So step 1 is always the critical numbers. So let's derive this thing. Let's find f prime of x and set it equal to 0. So f prime of x, if I power rule it, is going to be 2x will be 2 minus 3 times 2/3 x to the subtract 1, that'd be negative 1/3 power. And we're going to set this thing equal to 0. So 0 equals 2 minus 3 times 2/3, I'm going to cancel the 3. That's 2x to the negative 1/3 power. And now we have to solve this thing. So let's see. Why don't we add the negative 2x to the 1/3 power over here? So it's 2x to the negative 1/3 power equals 2. We could divide by 2 on both sides so that the 2's cancel to 1. And then we're going to have x to the negative 1/3 power equals 1, which means x is going to equal 1. So we get our final answer down here, x equals 1. There's our critical number, x equals 1. Well, there's one more critical number that I'm thinking of, and that's the scenario when does the derivative not exist? When is f prime d/e? That can happen sometimes, especially in a problem like this. Because it's x to the negative 1/3 power, remember we don't like negative powers and we often fix it. So if I was to rewrite this step right here and rewrite it as, we're going to write f prime equals 2 minus 2 over x to the 1/3 power, well, now we have the question of what makes a fraction not exist? What can we not have in the denominator of this fraction? We can't have 0. So x cannot equal 0. If we had 0 down here in the bottom, we would have a d/e situation. That means that's another critical number. So we have two critical numbers. We have 0 and we have 1. So on our table, we're going to set up our organized table like this. We have a left endpoint, we have critical numbers, and we have a right endpoint. And we have negative 1 is our endpoint, 0 and 1 are our critical numbers, and 3 is going to be our right endpoint. And we're going to take all those values and plug them back into the original. We're going to find f of negative 1, we're going to find f of 0, we're going to find f of 1, we're going to find f of 3. And each one of these gets plugged back in to what we originally started with. So the original equation, we're going to write here, was 2x minus 3x to the 2/3 power. So we have things like 2 times negative 1 minus 3 times negative 1 to the 2/3 power. And we're going to go through and we're going to do that for 0, for 1, and for 3. And at this point, I think you guys can do the math at home kind of on your own. So we're going to go through and just kind of find the values. So when you plug in negative 1, you end up getting, I'm going to make this a little nicer, you end up getting negative 5. When you plug in 0, you end up getting 0. When you plug in 1, you get negative 1. And when you plug in 3, you should get negative 0.24. I should warn you, if you're watching these videos and you're just assuming my answers are right and writing them down and you're never actually practicing, finding those values, you should try it on your own and make sure you do it right. You don't want to get to a test and realize you never really practiced this step right here of plugging everything in. Although it's kind of straightforward, it's a spot where you can make a lot of errors. So make sure you're practicing, I guess. And then, now that my table is done, I'm going to add a little column to the end here. And I'm going to look for the smallest and the largest point to find my max and minimum value. So the largest number, we have lots of negative numbers. The largest number is actually 0. That's going to be my max. So I'm going to write max over here. The smallest number I have out of this whole thing is my negative 5 up here. So that is going to be my min. And since the max at 0 occurs at 0, we have x equals 0 is a max. The min at negative 5 occurs at negative 1. So x equals negative 1 on the graph is a min. And then we are done. We have our answers. Now again, we have the luxury of a calculator. So I would recommend go ahead and graph this function on your calculator. Graph f of x equals 2x minus 3x to the 2/3 power. And you're going to get a picture of a graph that looks like this, something like this. And your min and your max should occur just where we expect it to. Now remember the interval was from negative 1 to 3. So negative 1 to 3. Which means we're only focused on at 3, here's 3, and at negative 1, right here. These are our spots of focus. So I'm trying to make a dotted line. It didn't really turn out very good. So notice that our highest point, if we had to find the highest point between here, happens at 0. Right here. There's our max. And our lowest point occurs actually on the edge of the interval down here at -5. There's our min. So it matches up with what our table said, which makes a lot of sense. So we have a min, we have a max, we're all set to go. Alright, I hope that helps. We're going to keep practicing this. Be sure, I think the biggest, most important thing out of this video is to note that it's all about organizing this table really neatly so that an AP grader could follow your steps. So don't just write like LP for left endpoint. Actually write left endpoint. If you start making up shortcuts for your table, like you just put C for critical numbers and you don't actually write critical numbers, how is that grader going to know what your shorthand means? They don't know you. They don't know your shortcuts. So you need to really, take the time to make this table nice and organized and take the time to do the labels. Okay, hope that helps. I will see you guys later.